Welcome to POWTS Chat for October 2024. Today, I'm going to be your speaker. So I'm Katie Petzel, wastewater specialist, POWTS plan reviewer, whatever you want to call us, for the Northwest portion of the state based out of Superior. So for those of you that I've met before, welcome. For those of you that I haven't, also welcome. I heard that we may have a group of apprentices watching today. So welcome to the program, and I hope that you all learned something here today. When you signed up for POWTS Chat, it probably said that we would have a special guest, unless you signed up very recently. That changed just due to some product review stuff. We thought it would be better to push that back another month. So hopefully in November, fingers crossed, we'll have our special guest in November. The topic this month is going to be individual site designs and more. So the first portion of the POWTS Chat today is going to be dedicated to individual site designs. And then the second portion will just be questions that were asked of us this month or topics that we thought pertinent to the fall. So, all right. So moving on here to the agenda for today. So we're going to go through 3 sections. What is an individual site design? Common individual site designs and how you submit them. So that'll be the bulk of the presentation. And then towards the end of the session today, we're going to do a POWTS potpourri. So questions that were asked of us, answered to the general group. Okay, so to begin with, so what is an ISD? So there are a few things in common usage in the Wisconsin POWTS program that maybe aren't super clearly defined. So A+4 being one of them, it's a trade term, ISD being another. ISD stands for individual site design, and it means exactly that, but I'll explain it a bit more in detail. So before we get to what individual site designs are, I thought it kind of important to go through how the code has changed through the years, because an individual site design is something that's unique to the modern Wisconsin sanitary code. So pre-2000, the Wisconsin sanitary code was a prescriptive code, meaning that there were standard designs and they were dictated in the code. What the code said is what you did, and any deviation from that code was a variance. So for an example, prior to sometime, year I cannot remember, but maybe later in the presentation I'd show how to look that up. Mounds required 24 inches of suitable soil. Anything less than that required a variance, because that was a requirement of the prescriptive sanitary code at the time. In July 1st of 2000, Wisconsin switched to what would be called a performance-based code. So the code is short. It doesn't dictate specific designs, but at that same time, there were component manuals introduced. So design guidebooks that help you create a standard design for most systems. At that same time then, because not everything fits in a component manual and we don't want everything to be a variance, individual site designs were also introduced to deviate from those component manuals that were produced in 2000 and have been updated since. In 2008, this is something that's incredibly important to a large portion of the individual site designs in the state. Fill was made to be no longer a variance. So prior to 2008, all systems needed at least 6 inches of the required separation distance to be in situ soil. So systems on fill were variances. I mean, not all, but many. And after that, after 2008, that requirement in the code was changed so that it's just for the component manual. So we can use fill as a part of an individual site design, and it's no longer a variance. So that changed quite a bit in 2008 as to how many variances were approved at the state and how many individual site designs were. The fourth big change, I guess, that would affect in the code that would affect individual site design happened relatively recently. So within my tenure here at the state in 2022, gravity at-grades were included in the at-grade component manual. Prior to 2002, they were all individual site designs, which on the next slide, I'll talk about the effect that had on the amount of individual site designs throughout the state. Or I guess it's a little bit later, but it really changed. There were a lot of gravity at-grades. So what is an individual site design? So an ISD is an individual site design, and it's a system design that does not meet the component manuals as approved under SPS 38410 3C or recognized under SPS 383-61. So those are the code sections that define, what a component manual is, how they're approved, et cetera, et cetera. An individual site design is not just a carte blanche, do whatever you want throughout the state. The system design still has to provide the same level of functionality as a component manual design would be, but they're just designed for the individual sites. So they're tailored to the needs of the individual site. Sometimes there are considerations out there that require us to deviate from the component manual, and that's when we would use an individual site design. They still are required to meet the requirements of the product approval in the code, but the possibilities are not necessarily endless, but they are much, much more open as to what we can do. Instead of just following the component manual and this is what we have to do, we can deviate from that a little bit as long as there's evidence and proof that it'll still function. So what's the difference between an ISD and a variance? Well, a variance petitions a section of administrative code and must show equivalency. It's the process for it is outlined in SPS 303. And an ISD is just a design that doesn't fully comply with the design standards of the component manuals, but will still function. So for example, if we are looking at setbacks, a variance would allow us to get closer to the setback than is allowed by code in the table in the code. Whereas an ISD would create a design that meets that setback. So we're not deviating from the code, but doesn't follow the component manuals. So for example, if we're on a site where the slope of a mound, 1 would get too close to the property line or cross it, we can create an ISD to shorten that slope so that we meet the setbacks. So what about an experiment though? What's the difference between an ISD and an experiment? So an experimental system has to follow the requirements of SPS 383-27 and is used for innovative systems that are used as an experiment. So experimental systems are supervised, they're pre-planned, they have a purpose, they involve 5 to 50 installations and require that the results and conclusions be shared with the department. And like I said, an ISD is just a system that doesn't fully comply with the design standards of the component manual, but it still functions typically one-off, individual, it's in the name, doesn't need to be supervised by a university or anything like that. So it's just important to keep these terms in mind when you're trying to describe what you're trying to do. Are you creating an individual site design? Are you proposing experiments, or are you proposing a variance? Because it does matter, and the code requirements would change based upon what you're proposing. So who approves? Who approves an ISD? Per table 383-22-1, POWTS that do not completely utilize treatment and dispersal technologies or methods either approved under SPS 384-10-2 or 3 or recognized under 383-61 are to be submitted to the department. So all ISDs are submitted to the department, approved by the department, regardless of the plan review authority status of the county. If a county has extended agent status for mounds, they still can't review ISDs. They all have to come to the state. It's just part of the deal. It's a code requirement. And if a person is creating an individual site design that is based upon the component manual of a manufacturer, we require that a letter be included with the plan review from the manufacturer or the representative approving of the design. As the component manual belongs to them, it is their approved manual, their approved product. We want their approval that this ISD will work using their product. So that said, how many ISDs are there out in the state? Well, in 2023, about 8%, a little over 8% of plans that were submitted to the state for review were individual site designs. So they're not rare. They're actually pretty common, and they used to be a lot more common. So prior to the changeover with Gravity Act grades, it was about 12% of plans that were submitted to the state were individual site designs. So when we think about Gravity Act grades, and we think, well, why were they included in the component manual? If 4% of systems that are being reviewed at the state are Gravity Act grades, and they're all following the same design, is that still an individual site design? No. So that's why it was improved. That was why it was included in the component manual. All right, So moving away then from the code sections and moving on to common individual site designs. We're going to go through a number of them here in the order that I felt was most common to least common, I guess. But these are the ones that we get at the state for review and some of the design considerations that are a part of them. So probably one of the most common are holding tank individual site designs. All component manuals can have individual site designs to them, and holding tanks have a couple of conditions that make them relatively common ISDs. So one condition that is common for individual site designs for holding tanks is a less than 5-day holding capacity. So the component manual requires 5 times the estimated wastewater flow, or 2,000 gallons, whichever is greater, for a holding tank. And sometimes there are conditions where that just isn't, it's not necessary, or it's not maybe a good idea for the site. So I'm just thinking of an example. If we had a large music festival that it was only open 4 days a year, and they're already there pumping everything, the porta potties and things like that every single day, would it make sense to have a holding tank sized for a full 5 days when it's only being used 4 days and they're already there servicing it? So maybe that 5-day holding capacity would just be too large for what they want to use at the site. But in order to do that, for the ISD to be approved, there has to be a letter submitted along with the plans from the pumper saying what interval they will service it at, and then it wouldn't be approved for less than that. But that's a possibility. Another possibility, another common ISD for holding tanks, is a holding tank that's located greater than 25 feet from an all-weather road. So the component manual specifies that the service access opening be less than 25 feet from an all-weather road. And for the ISD, a letter must be included from the pumper saying how far they're willing to pump, or that they're willing to pump that tank at that distance. And this comes up for a couple of different reasons. It could be an old building that that's how the piping works, and they don't want more pumping or suction lines or anything like that. Maybe there's floodplain considerations here. Maybe there's something else going on. Who knows? Another holding tank ISD that's not common but possible would be a site constructed one. So if you're doing a site constructed holding tank, contact product review prior to submission. And then non-domestic waste is probably the most common, and we're gonna have a whole slide on it coming up here. But for non-domestic commingled wastewater, for strictly non-domestic waste, it would be strictly a DNR review. But for commingled domestic and non-domestic wastewater, it is a individual site design, as the component manuals do not cover non-domestic or commingled waste. And it's a joint review by DSPS and DNR. So commingled systems. Commingled systems are those systems that have both domestic and non-domestic wastewater going to them. They can be holding tanks and components that do treatment and dispersal as well. For the review of the individual site design for DSPS, we require the concurrence letter be submitted from the DNR. Within the concurrence letter there, you can see an example of a picture of one to the left. There will be specific requirements from the DNR, and those must be followed for the DSPS approval. The thing that will be included in the DNR approval letter, and also a consideration that DSPS keeps in mind, is where is the septage or the holding tank waste going? It has to have a place to go. Industrial wastes are difficult to deal with, so we want to know that there's a place for it. Some things that people might not keep in mind when they're doing ISDs or when they're thinking of system designs is that pet waste is industrial, so you need to work with the DNR on that. And any food processing is as well. So I have a picture there from the Libby's factory where they make pumpkin pie filling. It's an industrial waste. So if you're commingling that into a system, it's going to be DNR DSPS review. All right, systems with fill. So systems that are utilizing fill. So systems that are utilizing fill as a part of the separation distance, part of the treatment component, are always an individual site design. The component manuals do not cover fill. There are no set loading rates for fill in the code. Fill is highly variable, so it requires an on-site from DSPS field staff. And if you are intending to utilize fill as a part of your component, notify the field staff ASAP so that we can arrange, and it doesn't arrange for a site visit so it doesn't slow it down. Some fill is better than others. I've been out to sites this year where the fill was okay for use, and I've been out to multiple sites this year where the fill was not okay for use. So it really depends on the quality of it. And just keep in mind that it's highly variable. You can go 4 feet one direction and it's totally different. All right, systems in fill. So systems using fill versus systems in fill. So systems in fill are also commonly known as sand blankets, and they're a common individual site design across the state. Different conditions will make it useful. So what is a sand blanket? What is a system infill? So a sand blanket is a system that is used when there are problem soils of some type, usually overlying a sandy material. Now I'm going to say usually a lot because individual site designs are individual to their site, but this is kind of when we see these used. So the problem soils are typically, usually a fill, an old system, a compacted soil, or something that you want removed. You're taking it out. But what's important to consider when you're doing a system infill is that the material underneath the sand blanket be able to assimilate the wastewater being introduced and that there is still sufficient separation distance, any limiting factor. Individual site designs are not a way to get around separation distance or anything like that. That's a code requirement. So regardless of what you do, you still have to meet the code. And it's important that these systems be put in systems where there's not going to be a bathtub effect. So if we're putting it in and removing a bunch of material, but the underlying material is a dense lodgement till, where is that wastewater going to go? So that's something that you should keep in mind. You're doing an individual site design for something like this. And it won't be approved if there's nowhere for the wastewater to go. We don't want to approve a system that's going to fail. Simple as that. So design standards for systems infill. Systems infill are pretty common. So there are some design standards for it. They're still individual to the site, but they're relatively common. So there are some standards to them. So all sand that's used in it when you excavate out and replace must be ASTM C33, just as it would be for a mound or anything else using as a sand component. The sand blankets are at least 12 inches thick. Simple as that. The basal area of the sand, like a mound, is calculated using the loading rate of the soil on which the sand will be placed. Depending on the soil conditions, at least 12 inches of sand is or may be required around the perimeter of the sand blanket to function as an interceptor drain. So if we're working in a tension saturated condition, we want to make sure that anything that is held in tension is not going to affect our system if it comes into the system area. So building out a 12-inch buffer. The components, the dispersal component for a sand blanket is sized at 0.7 for gravity flow and 1.0 for pressurized flow. And if the effluent is pretreated, the loading rate for that, the dispersal cell, could go up to 2.0. It's not common that we see that though. And the cell sizing is a maximum of 6 feet wide, as it would be for an in-ground system. A typical cell for an in-ground, and there must be 3 feet of separation between the cells, and then that can be ASTM sand. So the design it's based upon the component manuals. You can see bits and pieces of it from other component manuals coming together to create a system that's individual to the site. Important consideration also for systems infill is that EISA credit is not given to manufactured products. So you can't have this super downsized system. And that comes from the product approvals. They require in situ soil. So that's where that comes from. All right. Moving on then to another consideration that's common for ISDs is a greater than 1% cross slope. So in the code, there is a section that says systems should be designed with less than 1% slope unless otherwise approved by the department. So that allows us to do an individual site design for it. So when we are doing a design for this, we need to keep a number of things in mind. When we submit the design, you have to include what the dimensions are at each variable point in the system. So I have an example here of one that I just kind of made up. We're seeing a system that has like 1.5% cross slope, but otherwise it's on a flat site. It's not ideal, but it is what it is. And that's oftentimes why we're doing individual site designs, right? It's not ideal, it doesn't meet the component manuals, but we have to design something that will still work. So if we take a look at the D dimension there, this mound has a significant lift on it. And then with the cross slope, there'll be an even more significant lift at the far end of the cell. So it's a 100-foot long cell with that cross slope, the D dimension, the D2 dimension, meaning the other end of the cell, would have 1.5 feet more fill on it. So that's an important thing to include on systems like this because it does change the amount of materials required. It changes the construction practices. It changes a lot. Likewise, the I dimensions, the J dimensions, the K dimensions, they will all change as we are maintaining 3-to-1 slope, but the depth of fill is changing. So you need to include those dimensions on your system plans. A greater than 1% cross slope system must still maintain 3-to-1 slope unless it's specifying otherwise, unless you're doing an individual site design and you're also reducing the side slopes and things like that. But then you would want to include information on that. So, and in addition, the cross slope must not be so great that it prevents the wastewater from spreading and infiltrating into the in situ soil. So where the magic number is for that, I don't know. It would depend upon the site and the soils and everything else. It's an individual site design, so there isn't a strict line for that. All right, mounds with less than 3-to-1 slope. So as you all know, the mound component manuals, except for the mound in a box, Elgin mound in a box, require that the side slopes be 3-to-1 for stabilization, for safety, for a number of things. So if we are doing an individual site design for mounds with less than 3-to-1 slope, you have to include how it's going to be done. You know, what are the specific ways that it's going to be done? So I have an example here of a system that a portion of it will be less than 3-to-1 slopes. And why is it being done? The property owners love their beautiful maple tree. Whether or not it'll survive, I don't know. But an effort was made to save it. So what they're going to do there is they're going to construct a lined retaining wall for a portion of the system, and it'll be outside of the basal area. So that's an explanation of how it would be done. And it also explains how it's not going to impact the system so much, right? It's outside of the basal area, it's still stable. Typically, mounds with less than 3-to-1 slope have a retaining wall, a partial wall, or just steeper slopes. But they must be maintainable and long-lasting, and the minimum basal area must still be met. This is not a way to get around the minimum required basal area by the soils. So that's that. So there's a picture of that site so you can kind of see how tight it is and why it would be necessary. Sometimes mounds with less than 3-to-1 slope it's not because the site is so tight, it's because the site is really steeply sloped. And we'll talk about that, I think, in the next slide. So slopes that are greater than 25%. This is a requirement of all of the component manuals, except maybe the holding tank, I'm not sure. But definitely any ones that have treatment and dispersal, there's a requirement in the component manual that the system not be placed in an area that has greater than 25% slopes. So what do we do if the entire property has greater than 25% slopes and we can't avoid it, or that's the only good system area? Well, we need to then create an individual site design and include details of how that system will be safely installed and maintained. A lot of the 25% slope is about safely getting it there. We don't want anyone to be in that flipped excavator. We don't want anyone to die installing it, nor do we want grandma to roll down the hill on her lawnmower because she's on a 40% slope site and she's determined to mow it, right? So those are things to keep in consideration. What equipment will you be using? How will you be doing it? How will it be installed? How will it be maintained? You would want to maintain a 3-to-1 slope still unless you're specifying otherwise. At-grades should be pressurized on this. The at-grade component manual allows for gravity at-grades, but if there is a better way to do it and a way that will function better long-term, that's what should be done. So on a greater than 25% slope, we're also concerned about that wastewater being evenly distributed. So as gravity pulls it down, is it going to actually infiltrate into the soil? Pressurization spreads it out over a further distance than just gravity would. So for at-grades, pressurization it should be pressurized. An important consideration on ISDs for greater than 25% slopes for in-grounds is that there's still separation distance. You're meeting it. As we move through that slope, we lose ground very quickly, and that the cell will actually be located in the ground. So there's that. And another consideration maybe to think of when you're working on 25% slopes is, can the slope be cut for ease of installation and maintenance? Is there something that can be done to change the site so that the system is, a better system, but still won't affect the functionality of it. All right, so those are the common ISDs across the state. Like I said, it's non-exhaustive. There's a lot of different ISDs out there. Everything, it's individual sites, so there's a number of things that can be changed. So here's some not so common ones, I guess, and non-exhaustive. Systems exceeding the gallons per day requirements of the manuals. Typically, there's like a 5,000 gallon per day maximum of the component manuals. Anything above that is a individual site design. And they're not common because that's a lot of wastewater. So we don't see those system designs very often. Additionally, concave sites, there's a maximum percent of concavity that is allowable in the component manuals. So if you're above that, you're an individual site design. You're going to need to explain how this system is going to function in the same way that a system on a regular flat contour or a convex site would. Constructed wetlands, drip irrigation, sand filters, things like that. Those are now individual site designs. Some of them used to have component manuals. They don't anymore. We don't see them often enough to warrant having a component manual for them, but they're individual site designs. So they'd be designed to the site. Non-aggregate at-grades is something I was trying to come up with a list of things that, possibly that could be an individual site design. I don't know if I've ever seen one submitted, but it's a possibility if you, for some reason, really desired to do an easy flow at-grade. I suppose you could. You just need to explain how it works. And then the square feet per orifice. So if we're doing these huge systems, maybe the number of orifices would require, maybe you want to go up to 13 square feet per orifice or something like that. Possible, that's a hard line, and that would need to be crossed with an individual site design. So how to submit? How do we take our beautiful design that we have explained and think is approvable, and how do we submit it to the state? So you'll go into ESLA to your dashboard, go to plan review, select new application. It's very similar to a regular component manual review. There's just a few little differences. Once you get to the new application, you're going to go area plan reviews, program area POWTS, same as you always do, and then select permit type, POWTS individual site design. And this is for both holding tanks and systems with treatment and dispersal components. They all fall under POWTS individual site design. We see really often that people submit holding tank ISDs incorrectly. This is the way you do it. Application type, plan review. So we go there. Once we get through it, we enter our project and site information, our business information, all the normal stuff. But when we get to the question section, this will be a little bit different than you would typically see in a component manual. It'll ask, what type of individual site design are you submitting? Are you submitting a soil-based one? So a mound, an at-grade, in-ground, whatever. Or are you submitting a holding tank? So this is where you submit a holding tank, individual site design. You don't select it in the beginning. You select it here. So you would select that, and you would answer all of the questions, and the correct fee should pop up. So what are the fees? Here's, a selection from the fee table. So for soil-based systems, if the design wastewater flow is 1,000 gallons per day or less, it's $450 for a review. Above that, it increases incrementally at the same rate that it would for a component manual review. And for holding tanks, it's $180 typically, unless you're going above 5,000 gallons per day, which is not very common. So when people submit, they oftentimes will accidentally or through ignorance, I'm not sure, or a bad process, submit holding tanks for a $90 review fee. And that's incorrect. That fee is for a holding tank for a state-owned property. So if you go through it and you select individual site design and then you select holding tank individual site design, the correct fee will pop up. So I see a question in the chat. Someone thought that ISLA had switched to licensee. As far as I know, and I'm pretty ignorant when it comes to the background state processes, ISLA is sticking around for plan reviews for a while. I don't know if it's ever going into licensee. Licensee is for credentials right now. So everything that you do with credentialing is through licensee. Plan review submissions are through ISLA. Okay, on-sites. On-sites are almost universally required for fill sites. We want to see them. Simple as that. On-sites may be required for non-domestic or large POWTS, and they would need coordination, or non-domestic commingled. Sorry, I use them interchangeably, but I shouldn't. Commingled systems or large POWTS, and that would require coordination with the DNR. So if you need an on-site, or if you think you might need an on-site, contact your field person as soon as you know, so that we can set it up. We're in mid-October here. Time is of the essence. A lot of these sites, it may be waiting until spring. If the soil freezes at some point. It feels warm today, but what will it feel like tomorrow? So anyway, if you're working on one now, notify them as soon as possible. And then if you've been on site with someone and you've been holding on to that plan review for a while, notify the person that's been on site when the plan is submitted, because they're going to be the one that should do the plan review for it, right? They've been on site, they've seen it, they know the fill site, they know the fill soils, they know the considerations. So notify that person. All right. As a reference point for you, approval letters, if there's an individual site design, the approval letter and the plan review number will look slightly different than for a standard component manual review. So for individual site designs, the plan review number will end in .I. So I have an example down there, PWTS 0824000143-I. So I meaning that it's an individual site design. So if you see that, there's probably something going on there that makes it an individual site design. You want to know what that is if you're doing the installation or the review of it, so that you keep that in mind, that that's the condition that is deviating from the component manuals. Something that people might not know, but I thought useful to share, is for the PWTS number, the first 4 letters, the first 2 are the month of the approval, and the second two numbers are the year of the approval. So in that example of PWTS 0824, that plan was approved in August of 2024. So that might be interesting to you. And sometimes people will include in their approval letters, this is the language that I include on my approval letters. Not everyone does it the same. In fact, individual site designs are individual site designs, so there may be more or less information. I just include a comment that it has been reviewed and approved as an individual site design. So that's something to keep in mind if you're doing the inspection or the installation of these systems. All right, POWTS potpourri. So we have moved through individual site designs here, and we're just going to move on to the second section, the second big section of POWTS chat here today, which is questions, answers, and departmental updates. So our first update is going to be from Josh Rowley here. I'm going to stop sharing my screen and give Josh some time to talk about product review.
Good morning. So the only big thing you're going to see now is the Elgin GSF in-ground has a new approval. With that new approval, they need 6 inches of sand under their component, not the 12 inches that's always been required. They still need a total of 36 inches of suitable soil from the bottom of the unit to the restrictive feature. So that part hasn't changed, just the required sand under the unit, and they'll still get the effluent 2 loading rate with the 6 inches of sand. If anybody has any questions on that, you can let me know. And then I guess you'd have to determine on your in-grounds, if you have any in-ground systems now that are approved that aren't installed yet. Um, if they wanted to switch and go to 6 inches, I guess you'd have to decide if you'd want a revision then, because their system elevation is going to change. Actually, the system elevation is not going to change. They're going from 12 inches to 6 inches. So theoretically, there wouldn't be any changes other than that system sand. So from a state standpoint, I would allow a 6 inch lift as opposed to 12. But that's something we can discuss too if anybody has any questions. Um, there's also the Elgin Mound was renewed also. Their component manuals are combined now for the in-ground, the mound, and the mound in a box. So if you do pull those up and look at them, don't panic when you're looking at them. All three are in one manual, but each one has its own approval, so they'll expire differently also. Other than that, that's all I have for product stuff.
Thanks, Josh. Does anyone have any questions for Josh while he's on the line here? Okay. Well then. That's good. That means he's clear. All right. Next slide here. Okay, so code archives. Received a couple of questions, and I guess this also came up when I was creating my presentation of how do we find old versions of the code? How do we know when a certain line was added or deleted from the code? Is there an easy, oh, okay, we do have a question here for Josh for product review. Do we have a UV light product approved to add to existing vertically downsized ATUs, Josh?
Yes, they can. If the ATU itself is designed to have it installed, we could look at that. Otherwise, they'll have to add a tank because the flow through the UV has to be controlled. So in all likelihood, they'd have to add a tank for that UV unit. But we do have a UV unit that is approved. And it would work for the vertical downsizing for existing ATUs if they're taking that effluent to downsizing credit also.
Thanks, Josh.
Yep.
Okay, code archives, back away from product review, which is interesting, and back to code archives, which maybe isn't the most interesting. Okay, so how do we find old versions of the code? How do we know when a certain line was added or deleted to the code? So is there a magic bullet to finding out when the filter requirement came in for systems? In short, no, there is not. So instead of teaching, giving a man a code answer, I thought I would teach the whole group how to find it yourself. So in the beginning of each code section, so this is on the screen here, a screenshot from SPS 383. There is a section that has the general history of the code. And it goes back quite a ways, not all the way, but it does give you a basic understanding of what the code was called at certain points in time and when some changes were made. So if we look at this excerpt here from 383, we can see that the code has been called a number of different things over the years, and this will help you in your search for finding what the code was at that time, because if you don't even know what it was called, how are we going to know how to find it? So starting with 383, we had chapter H63. There were sanitary codes prior to this, of course, but this is when this history section kicks in. That was in 1980. In 1983, the code was renamed to ILR 83. So if you're looking for time periods there, you'll know it was chapter H for that time and ILR. after. At a different point in time, so in 1997, Iller was renamed again, COM 83. So that will be helpful for that time period. And then COM 83 was repealed and replaced. A significant code change happened in 2000, which we talked about, the change from prescriptive to a performance-based code. It was still called COM 83. And then in 2011, it was renamed again to Chapter SPS 383. So sometimes if you're searching for things, it's really helpful to know what the code was called at that time. And so that little section there can help you out basically from 1980 onwards. So for the last 40 years, what was the code called then? All right, but how do we find, we're looking at a specific code section and we want to know what does the specific code section say and when was this changed? When was a certain line added or deleted from the code? At the end of each section, so I have here the history section from SPS 383, section 43, there is an additional history section. So we can take a look at this and see when specific lines were changed in the code. So 383.43 is has a lot in it, but it also has the tables in it. So when were these changed? If we go into a PDF version or the online version of the codes, all of the things that are in blue are clickable. Which is really useful because the state maintains an entire code archive that is otherwise kind of difficult to find. So if you're referencing old versions of the code, I recommend using a digital version of it so that you can click these links and I'll show you what, if we click a certain thing, what comes up. So if we want to know what changes were made, to table 383.43.1, in between today and what was changed on the register of June in 2013 and effective July 1st, 2013, we can click that specific link for that date, that register, when was the code changed. And it'll open up a web page and it'll look like this insert here where it'll say, the bill for it, the register, what chapters were added, what were inserted, what were removed, and the final rules that were published. So if we click the inserted chapters here, because that's what we want to know, what it became after that, what came on that date, then we can go there and we can click it. We scroll through, go to the correct chapter. We're looking for chapter 383. Everything that was on that register will be listed in this. You can click on that and it'll open up the code as it was there, that specific time period. So if we compare the register for 2019, so a more recent version of the code, to the register that would pull up for 2013, so the code that was dated, June of 2013, we could see the differences there. So specifically, in 2013, the perk rates were still in the code. After that date, it was removed. And additionally, different soil application rates and things like that have changed over time. And so that's a really good way to reference that. And those history sections are at the end of each section of code. So you can take a look and see when specific lines were changed and then follow the links to find those versions of the code that were dated at that time. That's probably the easiest way to do it unless you have a printed version of every single code that's ever been printed, which would be a lot. So that's the easiest way to do it. Okay. Because we know, because everyone knows that digging through code is not fun and it can be a rabbit hole that maybe you don't want to go down. Some of the material from previous codes is included in the appendix to 383. So I have a screenshot here of the historic setbacks and separation requirements. There's a code comparison table for the POWTS code setback encumbrances dating back to 1914, the first codes. So this is extraordinarily useful in a lot of cases, because when we look at what things were in the past, a lot of times people are questioning what were the setbacks at that time. So if we take a look, all of the times the code have changed or the setbacks have changed are included in this table. So for example, if we go back to, oh, I don't know, just an example, the requirement for a setback to a cistern, it was removed in the 2000 code. Or the vertical separation distances have changed over time. You know, they used to be 3 or 6 feet, then they went to 2, 3, 5, or 10 feet, depending on the percent of coarse fragments and the soil texture. And now in the modern day, you know, we're at 2, 3, or 5 feet, depending upon, you know, if it's pre-treated or what the fecal contents are and the soil textures and coarse fragment percentages. So that's a really useful table in the code that can answer a lot of code archive questions when it comes to the setbacks. Okay, restrictive soil horizon. So this question came up. What do we do, you know, if we have a system that, this was an example from Matt, that there's a system that's going in, the infiltrative surface is at a 0.7, and then 1 inch below that, there's a 0.0 loading rate soil. You know, 1 inch, 2 inches below that. What do we do? You know, what is a restrictive soil horizon, and what are the considerations that we should take in mind when we're designing on these restrictive soils? So within SPS 383-44-4C, there is a requirement that the design of a treatment or dispersal component consisting in part of in situ soil shall reflect restrictive soil horizons that affect treatment and dispersal. So for instance, if we have that 0.7 soil and we are confident that the system elevation will be in 0.7, but we also know that there'll be a 0 soil a few inches under it, we probably shouldn't load it at a 0.7, right? Will that 0 loading rate affect the treatment and dispersal? Yes. I don't know how you get around it. It will. It's also important to keep in mind that some component manuals have strict requirements when it comes to restrictive soil horizons. So for example, the mound component manual, if you are installing it on in situ soils with soil application rate of less than or equal to 0.3 within 12 inches of the surface, the linear load rate is restricted to 4.5 gallons per foot per day. So it's important to check what's within a foot of the surface. And some component manuals have even stricter requirements for it. So the most recent update to the GeoMat in-ground component manual has a very strict requirement. You know, it's 0.4. So it's different than what we would typically see that limits that linear load rate. So these are things that are incredibly important to keep in mind. Sampling. As we enter into winter, you know, we're going to be doing, some people will be doing more complicated designs or the ones they didn't have time for this winter. And some of those systems will require sampling. So sampling requirements are used when we are looking at a system that may be considered high strength. So commonly we see this with bars and restaurants that already exist and are upgrading their systems. The sampling requirements are within the code, and in order to sample as, you know, regular strength effluent, you have to meet the parameters in SPS 383-4.2. So those being the standard domestic strength effluent strengths. Sampling requirements are that the samples must be taken within a 30-day time frame with 6 individual samples on 6 different days. There's nothing in the code that says, oh, it has to be, you know, once a week for 30 days. Well, that wouldn't even fit because we need 6 samples. It needs to be a representative sample of the system's use. So if we have a bar that is only open Friday, Saturday, Sunday, you should not take your samples Thursday, Wednesday, Tuesday when there's no use. We want to actually sample so that it's representative of the system's functionality and how we will best treat our wastewater. So that's important to keep in mind as we work on more complicated designs as we go into the winter. All right, system construction. We have a picture here of a gentleman in Alaska or somewhere like that who is drilling into a permafrost. We don't want anyone to be this guy. In fact, we don't want it so bad that it's a code requirement. So within 383.45, there are restrictions on frozen soil and on snow cover. So any POWTS treatment or dispersal component consisting in part of in situ soil may not be installed if the soil is frozen at or below the infiltrative surface of the component. So don't be that guy. In fact, you can't be that guy. The code says you can't. The soil must not be frozen at the infiltrative surface or below. Additionally, snow cover shall be removed before excavating or installing a POWTS component or dispersal components consisting in part of in situ soils. All right, lamellae versus bands. We just had our soil training sessions, 2 of them in Anago and in Prairie du Sac, and they were great. But we talked a lot about soil forming factors and different descriptors of processes in the soil. And this came up a little bit. So lamellae, what are lamellae? Bands, what are bands? And when should we be using these terms? Are they interchangeable? No, they're not interchangeable. So lamellae, it's a specific pedogenic or soil forming process that create lamellae. So they are wavy, thin plates of fine textured soil in a sandy matrix. They are created as soil forming processes, bring clay down, and they are forming like mini BT horizons in the soil. And so what is a band? Band is a more general term, but typically they are any layers in the soil, but usually they're depositional in nature. So if we're in a floodplain soil or in a soil that has been deposited, depositional in nature, deposited by whatever it may be, then we might see bands in the soil. So these terms are not interchangeable, and I'm guilty of using them incorrectly. But if you're going to be including things like this on your soil reports, just be confident that what you're describing and the terminology that you're using is appropriate for the actual soils on the site. All right. County ordinances. So this is specific to some of the work that the counties try to do over the winter. Many counties, I know when it comes to be winter time, they want to work on their ordinances. But it's just important to keep in mind that the code requires that the government unit submit any proposed ordinance or proposed ordinance revisions relating to POWTS a minimum of 30 days prior to the first scheduled public hearing so that DSPS can try to review it and keep you within the requirements of 383. If you know that a county ordinance, POWTS ordinance change is coming up, notifying your plan reviewer, your POWTS staff for your area more than 30 days in advance is more than welcome. We'll try to be as helpful as we can. Okay, Wisconsin Fund. So what's going on with the Wisconsin Fund? But it's the time of year when disbursements start to happen. So what's going on with the Wisconsin Fund? So currently, as per the 2023-2025 budget, the Wisconsin Fund is, it's not included past 2025. So what does that mean? It means that right now DSPS is not accepting applications for the Wisconsin Fund. And if there were 2024 installations, as of the next funding and the budget cycle, they wouldn't be funded, but that's not, we just don't know what the budget will be yet. It's not included yet. The budget hasn't been written or released yet. So I guess what I'm trying to say is don't count on it, but maybe it'll be a pleasant surprise if it's there. So what does that mean with last year's applications? Well, the funding in the future doesn't affect last year's applications, but they are currently working on processing the disbursements for them. So DSPS Fiscal does that, and they're hoping that it'll be sooner than later when those are paid out. So if you have questions specifically regarding the Wisconsin Fund, I would reach out to DSPS Fiscal for questions about that. All right, so that is what I have. We're at 9:57 here, so I think that I think you got an hour's worth of talking out of me.